Now that we know the meaning of potential difference and current, we can use those quantities to determine other things that are of interest to us. For example, a common question is, how much energy does a certain electrical device use up? In a typical electric circuit, we can consider the charges as gaining energy when they go from the negative side of the battery to the positive side. They then give up this energy when they go through the electrical device, providing the energy for the device to do whatever it is that is of use to us. By the way, note the up-to-date graphics in this slide. By definition, the potential difference is the amount of energy transferred by the electrical device to some other form of energy per unit of charge passing through the device. Now, the current in the circuit is the rate at which charge flows through the circuit. So, the potential difference multiplied by the current is the energy transferred per charge times the charge transferred per time. This gives the energy transferred per unit time. This quantity is called the power.
Now, AP problems don't usually ask about power. They ask things like how much energy is dissipated per second in the resistor, or they ask about the brightness of the light bulb, which depends on the power. The brighter the light bulb, the more power it uses up.
Power is measured in a unit called a watt. 1 watt is 1 joule per second, so that also equals 1 volt per ampere. This is the same watt that we used in mechanics. Electrical companies don't measure energy in joules typically. They take a measurement of power, a kilowatt, and multiply it by a unit of time, an hour, and they refer to kilowatt hours. We can express our formula for power in a variety of different ways. For example, since power is equal to voltage times current, and voltage is current times resistance, then the power could also be the current times resistance. That gives us P is equal to I squared times R. Similarly, since the current is the voltage divided by the resistance, the voltage divided by the resistance times the voltage should also give us the power, and that gives us delta V squared over R.